So welcome everyone. Thanks for joining our Steidle Café this morning. As a reminder, this semester we're celebrating the 115th anniversary of the Department of Material Science and Engineering at Penn State. And last year was the 125th anniversary of our College of Earth and Mineral Sciences. So in celebration of these two milestones, we'll have a number of alumni joining us this semester and sharing their wisdom during our Steidle Cafés. And these are our fellows. So today we have with us Dr. Kristen Brosnan and Dr. Michael Schmidt. We'll start off with Dr. Brosnan. She joined Collins Aerospace in June of 2021. Prior to this role, she served as the Technology Director for Superior Technical Ceramics and before that, until 2020, she was a Technical Manager for the Metals and Ceramics team at GE Research in Niskayuna, New York. She currently serves as a board member for the Materials Research Society and previously served as the chair for the Basic Science Division for the American Ceramic Society. In terms of her connections to Penn State, she received her BS in Material Science and Engineering from Georgia Tech, and then her MS and PhD in the Material Science and Engineering Department from Penn State University, and was advised by Dr. Gary Messing. So thank you so much for being here. The floor is yours.
Hi, so is my screen sharing right now?
Yes, it is.
Okay, and you see the full
Yep.
screen?
It looks great.
Okay, awesome. Well, thank you. First of all, thank you so much for having me here. I'm just really thrilled to be talking to Penn State students and to be back at Penn State, so to speak. So thank you, and hopefully I can come in person soon. So today I'm going to talk about an exciting career, I think, in material science. And I like to just say that this is a work in progress in full transparency. And I'm happy to answer any questions. I did focus more on the personal because I know that sometimes when you're, especially in my career, I've been faced with a lot of personal and family oriented challenges, and those are harder to get answers on. I know as a student and then later a graduate student, there was very easy to get technical advice from mentors, but getting the personal advice on how to navigate different career challenges was a lot harder. So I tried to focus on that. And I hope that at least coming out of this, you will all see that, everything, thank you for the very nice introduction, Allison, but everything doesn't always line up in such a perfect, I guess you could call it like the Facebook version of what a career could look like. And there are a lot of bumps in the road and a lot of challenges. And I want to walk you through what I went through in the time we have. And I'm of course happy to connect with anyone afterwards. And if you have any follow-up questions, I'm happy to talk through and at least on how I made my decisions and what I went through. So we'll get started. I guess I'll skip to the next slide here. So I actually just joined Collins Aerospace. We're part of Raytheon Technologies in June of 2021. And I'm basically, I left an engineering role and joined business development. It's still a technical role. And I support a wide variety of products and platforms in the advanced solutions in communication, navigation, and guidance, specifically microelectronic packaging. And so you'll hear a little bit later how I started actually in electronic ceramics, and now I'm back in the electronic material world. And so I very much focus on early TRL technology and try to find successful homes for them within the company. So Collins Aerospace is one of 4 businesses within Raytheon Technologies: Raytheon Missiles and Defense, Pratt & Whitney aircraft engines, Raytheon Intelligence and Space. So those are the other components, and we are the biggest in terms of sales of Raytheon Technologies, and many folks don't really realize that even Collins is a part of Raytheon, but we are even the biggest business within Raytheon. I have other very important roles in my life, as well as working at Collins Aerospace, and these roles are, first and foremost, I am a mom. I have 4 kids. I'm a wife and daughter, and family is very important to me. I am on the board of directors for MRS. Community and service back to my professional community has always been a very important part of my career and my life. And I never really expected much back from that. but I'll tell you about how that actually really positively impacted my career. And I didn't really realize that until at least 12 to 14 years in. And so I think, staying involved, if you are involved in a professional society, is definitely something that can bring you a lot of joy and happiness, and being able to see your friends and colleagues at conferences, and also could help you if you hit a bump in the road, down the road. American Ceramic Society also been a very important part of my life, my professional life. I coached basketball for the first time this winter, 2 teams, in fact, my daughter and my son's team, and had a blast. I definitely encourage all of you to take time away from the work activities and professional activities and do other things like that. And that was just one of the most exciting, and I'm going to sign up and do it again next year, and maybe soccer too. And I'm also a board member at the in the Vermont Manufacturing Institute. So a little bit of background about myself. I am from Tabernacle, New Jersey, so not too far away. A lot of Penn State, a lot of folks went to Penn State from New Jersey. Somewhere in the Pine Barrens, we had cranberry bogs and all that kind of stuff. Went to Shawnee High School, and I always get asked what exit that I was near in New Jersey. I don't actually know, but if I had to guess, I think it's around 7B. We seem to be pretty far away from the turnpike, but so that's a little bit about me and where I'm from. I did go to Georgia Tech for undergrad, and then that kind of led me, because I was working on transducers with Joe Cochran at Georgia Tech, and it led me to look at Penn State because they had the electronic ceramics at Penn State, and they were Bob Noonan was doing a lot with the transducers, and so I met with Gary Messing and did my master's and PhD with him on textured piezoelectrics. I don't really want to go into a lot of details on my PhD dissertation, but it was a very cool project where not only kind of the fundamentals of how do you increase the piezoelectric coefficient using grain-oriented ceramics, but then building it and putting it into a device and measuring the device properties. And I think that this, having that fundamentals and then also putting it into device and measuring the application properties, from a very early stage, I was really interested in the application. And that kind of is a thread throughout my career in being very application oriented, but also interested in the fundamentals. So I would say if you have an interest, or if there's something like that you grab onto when you're in school, even if it's a different technical area, go with it, because it can be a lot of fun. I was also that's when I started my involvement with ACERS and Keramos, was in graduate school at Penn State. So a couple words of wisdom: enjoy this time. It doesn't last forever, although some days it's going to feel like it could. But you really want to enjoy this time, because it's a special time when you're in school, and everything after that is a lot harder. And then the other thing, when I was at Penn State, my other graduate student friends that we would go and drink beer at the saloon together with, now they are collaborators. They are friends. I've hired some of them as consultants in roles that I've had. They're my colleagues. They've helped me, find people to fill positions. I've worked with them on projects, external programs funded by the government. They've been program managers of mine. They've been co-PIs of mine. They've been customers. They've been suppliers. And so the folks that you are with right now in school, they are going to fill all these roles as you navigate your career. And I think, just keep this in mind. I think that this is a great time to build these relationships, and because they will be with you for your career. And I don't know if Gary is on this call, but school is a job. And I don't know that I really entered it taking it that seriously, but I definitely left it feeling that way. And I feel like, it is a job. Take it seriously, because it will set the stage for the rest of your career. And the good news is if you don't like what you're working on technically, you may never work on it again. So I worked on electronic ceramics, and then I worked on ceramics that went into gas turbine engines and solid oxide fuel cells. And so I really didn't touch piezoelectrics again for the rest of my career so far, but it could come back. And now I'm in like looking at passive components for packaging. And so this is coming back, and it's really exciting because I do have that background in it. Just doing a quick time check. I know we probably have to move this along. So I have some great memories of Penn State. I worked in the Steidle basement. Free food never leaves you. Rothrock State Forest, spent a lot of time out there. Group pictures and group activities, and you make lifelong friends. I also have some, experiences that I'd like to forget, like taking the qualifier exams for my Ph.D. a couple days after 9/11. That was really hard. Being broke all the time, it does get better. And the Steidle basement, good memory, but also one that I'd like to forget. I hear it's been renovated, so maybe it's not such a scary place anymore. So kind of just like a career in a snapshot, I left Penn State. I became a material scientist at GE in 2007. I worked on solid oxide fuel cells and led government funded programs on SOFCs for a number of years. And then I became a manager of the ceramics laboratory. And so I had a group of about 12 scientists, and we were working on technologies ranging from solid oxide fuel cells to gas turbine engine applications of ceramics like thermal barrier coatings and ceramic matrix composites. Very exciting. And it's like no good deed goes unpunished. And so after that, it was like, why don't you lead metals and ceramics? And so I took on that role. And I'll talk a little bit about the decision to leave GE after 14 years, but took a role as a CTO for a small manufacturing company in Vermont, and then quickly left that role and joined Collins Aerospace. And I just want to kind of focus on those last two changes because they were very personal and humbling in a way. So I'm going to skip over a couple things. One thing I do want to mention though is one lesson I definitely learned is if you don't ask for something, the answer is always no. When I met my husband, we lived 120 miles apart. We made a handshake deal to have kids, and these beautiful, now 10 years old babies arrived, and we lived 120 miles apart. And so I asked for a remote work arrangement. Again, this is going back 10 years ago, before COVID, and remote work in the technical role was even something, companies entertained, or at least at my company, in a technical role. And it's a good thing, I made it work because we didn't have a remote work policy. And after I did this for a number of years, we did this for 6 years, I made remote work a possibility long before COVID, and it's a good thing I didn't screw it up. But I think we knew even back then that this was possible and that we can make this work. One of the themes of being a manager is I always, and it's the same approach I take with my customers and my team today, is I really like to focus on the how can I help? You're going to go through some rough times. There's going to be layoffs. There's going to be an interaction with an employee where you may have to let them go. And I always try to lead these conversations with compassion and empathy, and start every one-on-one with a team member with how can I help? Like, how can I remove your obstacles? What can I do to make your life easier? I really felt like that was my number one job as a manager and as a people leader is, it wasn't the technical. I'm not technically stronger than anyone on my team. They are the technical experts. I'm there to help them and make them successful. And I learned that from my now retired boss, Margaret Blom at GE, and she was an extremely influential person on my career. And that was her words of wisdom to me that I'm now passing along to you. So one thing I do want to say is be a good human, celebrate the anniversary, say thank you, have fun, mix work and friends. Some people will tell you the opposite. this is the approach I took, and I like literally love my teammates and have fun with them. When you want to go to work every day and you want to spend time with people, this is a good thing. And you're going to have technical discourse, and it's easier if you're friends and you're helping each other. So I did leave GE and my wonderful team in the summer of 2020 in the height of COVID. And I just want to spend a minute talking through this decision, because it really was for my dual career with my husband. My son was graduating high school, so we didn't have a reason to stay in New York except for my role, but his work was mostly in Vermont. And so I had this opportunity. I was called by a recruiter to apply for this role as a CTO type role for the small company. STC, wonderful people, make a lot of different variety of ceramics for aerospace and energy applications, semiconductor industry. Couple key points: I negotiated my offer. First time I ever did that in my career, and I definitely recommend everyone here do that. I knew that there were risks. There were red flags. I was okay with that. I needed to look at an opportunity in Vermont for my dual career situation. And changing jobs is hard, especially when you've been in one place for 14 years. I had to make a resume. And this was a bigger role, not just having a team of technical people, but I had IT, quality assurance, materials engineering. So I was used to that. And then also manufacturing engineering. So I had to learn some new areas. And so it was definitely a growth role. I'll go back to, I knew there were risks and I was okay with that. And my gut told me I have a really strong opinion about this. And thank goodness I made the change and I did this, because I learned a lot in that 1 year. And I also knew, I was okay with, if it's not working out after 3 bosses, 3 CEOs, I decided I'm going to look for something new. And I've been extremely happy in my role at Collins Aerospace in the 7 months I've been here. And I'm back on early TRL technology, helping to find homes. And don't be afraid of change. It is a new beginning. I truly believe this. I have some advice, but I know we're short on time, so I'll just end it here with, sometimes the best career moves are the ones you don't plan and didn't know you wanted. And I truly believe that. So I just kind of summed up some of my advice. I know we didn't go through all of these topics, but I did want to leave time for questions and to talk through anything you have to ask. So thank you.
Great, thank you so much. To those of you in the audience, you can type your questions in Q&A or chat. I guess chat is preferable, or if you raise your hand, we'll just call on you to unmute. So please go ahead and type in your questions now. I was going to ask sort of what was the most, so you alluded to the fact that, changing the job was difficult and so forth. Was there a particular thing in your current role that was challenging, especially, maybe conflated with COVID and everything, to go from your previous position to this one? What would be the hardest thing?
Yeah, so I basically left a materials focused role so most of the technical experts that I work with mostly have electrical engineering and physics backgrounds. It's a lot of circuit analysis, it's a lot of software. So not just the packaging, but how do you program it? And so it's a very, communication, navigation, and guidance is a very different field from, I guess you would say materials is more the hardware part of it. So, I'm learning a lot about radios and how radios work. And to me, it's exciting. I really think I'm a lifelong learner. While I was at Penn State, I don't think I ever had a semester where I didn't take a class throughout my Ph.D. and my master's, even though that wasn't required. And so I think it's exciting, and it keeps it fresh, and it keeps it exciting to be in a new area.
Great, thank you.
That was the biggest challenge, is that I knew nothing about communication systems, radios, and the different types and waveforms. I had to learn all of that. I'm still learning.
Great, thank you. Are there any questions from the audience? Okay, so there's one that came in that says, you said this was the first time you negotiated for your position. Did you have anything that made that difficult to open up that communication?
So as a manager, I used to coach my candidates, like, negotiate with me, like, on the down low, like, you need to negotiate this, because I actually found that certain demographics wouldn't do that. You know, I could definitely tell the difference between the male female demographic, but there's also cultural demographics that would not negotiate. So I would tell my candidates as a manager, and I did a lot of hiring over my 14 years at GE, you know, you should negotiate, there's room in there. And I would tell students this at conferences to make sure that they do that. I knew after starting at GE within a couple of years that I hadn't negotiated my offer, but my colleagues had. And, you know, just to give you an example of like how this can impact you, you know, after 10 years, if you start at a few $1,000s less than your colleague, you know, raises and percent raises on top of that, I mean, it just compounds that difference. And so negotiate your offers. What is the worst they can say? No, they're not going to not hire you for trying. Trust me, everyone else is.
Great, that's great advice. So there's one last question. I know you're going to have to leave soon, but this one is, how did diversity figure into your career path? This one's from your advisor.
So I think, you know, it certainly, I guess the part where it figured in is I was very keen, particularly as a manager, when I started building my team and I had a way to build my team. I looked at diversity as cultural diversity, gender diversity, diversity in degrees. There was definitely some, I would say, cultural aspects, you know, of how teams were run when I started as a manager of the ceramics laboratory, and how I wanted to take that to a different level. I wanted diversity in gender. I wanted diversity in degrees. Like, I didn't think everyone on my team needed to have a Ph.D. Because, you know, we only had so many PI roles and we needed hands in the lab to do activities. And so I think that it factored into my, you know, particularly in my role as a manager, and just realizing that having a diverse team, and there's so many different aspects of diversity, can make you have a stronger team. And I think that that's true. And but I felt like it having a eye for it and having it first, like, I didn't even interview candidates until I had a diverse pool. I just refused. It's like, I've just kept trying to pull resumes and keep going at it, because I didn't want to start that process unless I had a diverse pool to start with. I don't like to be on panels if I'm the only woman. I want there to be, you know, I mean, it's one thing when you're a panel of two, but when you're on a 6-person panel and you're the only woman, I've pushed back and said, hey, like, is this really what engineering looks like, or we want it to look like? Like, you know, find another woman and I'll sign up for your panel. So that's how I felt like, as I grew my role and had more leadership, I was able to advocate and be a better advocate for it than as a young engineer.
Great, thank you so much. Okay, so thank you very much for your time and sharing your path with us and your advice. I know we all really appreciate it. So, and we look forward to when you're back here at Penn State.
Yeah, feel free to reach out. I have put my contact information, and I'm happy to talk one-on-one with anyone.
Great, thank you so much. Okay, so our next speaker today is Dr. Michael Schmidt. He is the CEO at Hammer Industries, LLC. Hammer specializes in developing advanced materials and manufacturing processes for materials and components in extreme environments. And in particular, some of the things that they target cross-cutting applications in energy, aerospace, and defense, including hypersonics, gas turbine engines, nuclear propulsion, nuclear fuel storage, corrosion, and molten salt. So Dr. Schmidt received his BS and PhD in material science and engineering from Penn State University. So thanks so much. The floor is yours.
Thank you. Thank you. I'll start sharing my screen here. Everything look good?
Looks great.
Good. So thank you. It's a pleasure to be able to speak today and to be invited to speak today. and I'm honored and excited to talk to everyone. I think today I want to carry actually some similar lessons that Kristen had, and one of the kind of common themes we'll have in my talk is that, you know, keep a dream in mind, keep a goal in mind, you know, make sure that you have something that you're working towards that you want to do, and that can help guide you. You don't necessarily need to know kind of every step in your journey, but if you have kind of that end line goal or that dream, that can help guide you, and that'll be an important part. And it was definitely an important part of my journey. So I'm also a little bit earlier in my career than I think a lot of my colleagues that'll be giving these talks. So for me, I hope that I can connect with the students, both undergrad and graduate students. I'm not that far out. The pain of grad school is still very vivid in my mind. So I understand the struggle. And I still, you know, just recently kind of made a lot of the decisions that you guys are probably thinking about. And likewise for those that are maybe early career, I'm right in the thick of it with you. So with that, I'll get into it. So first, I'll start with just kind of like a snapshot of where I am, who I am. I live in Houston with my lovely wife, Sasha. You can see the skyline. There's a lot of cool places in Houston. If anyone ever gets the chance to visit, I would highly recommend. I have two amazing little boys, 5-month-old and a little over 2 years old, Asher on the left and Koa on the right. They keep us busy. So we are potty training, we are sleep training, we are exhausted, but it's great, it's rewarding. And we enjoy it. We love the little guys. The middle image I wanted to show is just, it's a pretty cool thing that happens here in Houston every summer. We have the Saharan dust that kind of comes and dumps over us from Africa. And the cool thing it does is change the sky. So, you know, for like a week or two, we get these pretty wicked sunrises and sunsets. And that's my house there on the left. So other funky thing about Houston is, you know, it's a downtown area. So growing up very rural, as I'll get into, being in State College, not super dense. Houston, a little more dense. So they build these houses kind of small and tall. So we live in this sort of little square 4-story house, and that's common throughout the area. But it's a fun area to live. There's a lot of activities, a lot of food, a lot of culture, a lot of diversity. And those are things that, coming from where I came from, are not something that I was used to, and I love it. And then just kind of fun things that I like to do and about me. We watched the Netflix Drive to Survive, my wife and I, and we got super into Formula One racing. And we actually had the opportunity to go to a race in Austin this past year, and it was awesome. It was one of the coolest experiences I've ever been to. We really enjoyed it. It was really cool to see the cars, and then kind of the nerds inside of us got super into like the technicals of how do they build these cars and the carbon fiber and all the materials that they use, and everything else that goes into actually making them work. I think most people are just like, oh, that's cool. And we're like, how do they engineer that? How does that engine work? So that's been a lot of fun. Everyone kind of picks up new activities during COVID. For me, we got into some art, particularly doing like acrylic pours. So I showed one at the bottom that turned out okay. It's very hit or miss. And when you're like a technical brain, like a lot of us are, you see, you know, all the faults and everything else. So it's really hard to just kind of go with it. And this style of art is like the absolute opposite of control and technical and everything else. You just pour it and see what it looks like. So it's been a lot of fun taking me to a new area. In my spare time, I still like to game even as a grown man, and I like to power lift. So those are two things that kind of keep me occupied when I do find those slivers of free time outside of hanging with my boys. So the start of my journey is a little bit different than maybe some others. So I grew up in a very rural area, Hughesville, Pennsylvania. Population was 2K, but in an area that was the size of Philadelphia. So a couple of orders of magnitude lower population density. The image at the top right is a look out my backyard. I couldn't see my neighbors from where I grew up. We lived on a 20-acre, some people would call it a farm. We had horses, we had donkeys, chickens, dogs. So I grew up in sort of a very different environment than where I am now. And I really enjoyed it. It gave me a lot of perspective, and I take a lot of those things with me to this day. I was the youngest of four, so I was always getting knocked on for being the baby, for being favored and everything else. But it was great. I got to learn from my siblings. I had people that I could ask questions, people that I could leverage their knowledge and their experiences, and I definitely wouldn't trade that for anything. I dreamed growing up of being one day a fighter pilot. So matse researcher scientist was not my dream when I was little. I wanted to be a fighter pilot. And then eventually I wanted to be, I think in junior high, it peaked of a NFL player. And then once I realized I wasn't going to grow anymore, I said, all right, well, the Iron Man movie was pretty cool. Maybe like a Tony Stark type person. So it's kind of silly, but the reason I bring those up is it's important to have dreams, to have, something that you want to pursue, an end state that you want to get to. And I think that can help guide us and kind of help us make the decisions as we're moving forward in our careers. So, when you're graduating with your bachelor's, what do you want to do? Well, what's your goals in life? You don't have to have life figured out. You don't need to know your path, but it is helpful to kind of know where you want to end up. So, and somewhat contradictory to that is that though I think, in my opinion, should have dreams and should have kind of a goal in mind, you don't really need to know the path. And I certainly didn't at the time as I was growing up, and still don't really know what my path is going to be. I'm not the type of person and don't really believe, frankly, that you need to lay everything out and have this hard path, because as soon as something changes, it's going to be a struggle. So for me, growing up, I didn't have a favorite university. This might be sacrilege, but I wasn't like a Penn State guy growing up. I didn't really care about universities in general. My dad went to Pitt, my mom went to Duquesne. We had family that went to Penn State and all over the place. And I wasn't really rah-rah for any team. And I didn't really have a major either. I just knew that I liked science, and that was kind of something I wanted to do. I read an article in National Geographic, and it was about nanotechnology. And this is kind of right when that was peaking, and the buzzword of nanotech and nanotubes and everything in early 2000s. And I was like, that stuff's awesome. That's what I want to do. So, Google search said that's not really a major, but the closest thing is material science. And hey, right in your neighborhood is Penn State, who's pretty great at that. So I decided, all right, I think that's what I want to apply for. That's where I want to apply. I applied to Penn State, did the early application, and accepted that early. So my decision wasn't really laid out. I just sort of went with where the river took me. But it was very beneficial. I was able to get into the major and at a really good school for that major. So I went from a small town to State College, which is really just a bigger small town. And my freshman and sophomore year, if you had to title that, it would probably be what not to do. I majored in matse, knowing nothing about it. I went to the Earth and Mineral Science totems, which is kind of, for those less familiar, an introductory way for incoming freshmen to kind of dip their toes, meet each other and everything before everyone comes in on that move-in weekend. So you can kind of come in with some experience and understanding of what the college is, who are going to be your peers, some of the faculty and administrators. So it was a really great experience. And that actually also showed me how clueless I was, because other people are talking about what their focus is going to be for matse and ceramics and electroceramics and polymers. And I was like, I didn't know we had to pick that. So I really came into that somewhat ill prepared. I was prepared from an academic standpoint, but that was also a problem because I took all the easiest classes I could, did well in those classes, and then was like, everyone said college is hard, it's not so bad. And then I got out of the classes that I hadn't taken before, and that was a wake up for me. And then also freshman, sophomore year, I probably focused a little too heavily on exploring the cultural side of PSU. I think I never missed a whiteout or a game. I never missed a tailgate either. So there were things as a freshman and sophomore that decisions I made that I could have made better. But at the same time, they set me on the right path to succeed. And the turnaround point for me was my sophomore year. And the reason I bring these things up is I hope some other students might be able to connect to that. You don't always have to have a great start, but you can change things around, and it's never too late to change things around, regardless of where you're at in your career or what you're doing. For me, that turnaround point was my sophomore year. And the big thing was I joined the Wolf Research Group the summer after my sophomore year. So for me, I didn't have a great GPA. I just started to realize that I should take this more seriously. And I needed to get some research experience, some internships, and really turn things around. So Dr. Wolf took a chance. He saw that I had potential, might not have had the best GPA, but he thought that I had potential. And I'm really grateful for that opportunity. If there's one person that I had to thank, for giving me probably my most important opportunity and putting me on the right path, it would definitely be Doug Wolf. He forced me sometimes, we might have butted heads a little bit, but he forced me to actually work to my capacity. So that experience as an undergrad was really important for me and critical for me, and set me on the right path. And then, that's if there's one person. If there's one kind of class to say that set me on the right path, it would definitely be Crystal Chem with Dr. McKinstry. So, you're taking all these general classes, and then suddenly you start taking classes where it comes to fruition. You understand how all this chemistry and physics and everything else that you've been taking, how that actually works and how that's going to impact things. So I remember just being blown away by, okay, here's a material, alumina, and here, if you add this extra titanium or chrome to it, it's going to change the color, and here's why, and here's the bonding and everything else. So crystal field theory and all these different things that just kind of blew my mind. And I was like, this is amazing. This is what I want to do. It's so cool to actually have these things connected and see real world applications for it. And my interest between that and the research that I was doing in Wolf's group was piqued. And I decided that's what I want to do in my career. I want to do research. The problem was it was a little late to decide that. That was the end of my junior year. And people told me, yeah, if you want to do research, if you're serious about it, you pretty much need a PhD to do that. And I was like, okay, what do I do for that? And they're like, well, you have to apply to grad school. You have to have a GPA at least over 3.5 and, preferably closer to like 3.8. And, you need to be applying in the next 2 months. And I was like, oh, that's not good. So I quickly started the application process, was able to apply successfully and enter grad school. So the major factor for me for grad school was applying to a NASA fellowship. And for me, I wanted to continue the research that I had been doing. So I continued working in the Wolf Research Group at ARL. There we primarily focused on small business innovative research programs, working with small businesses who are trying to commercialize and transition technology. And that was focused on thermal barrier coatings for gas turbine engines or jet engines. And then concurrent to that, I was working on a NASA fellowship and co-op at NASA Glenn Research Center under Dr. Brian Harder, also on thermal barrier coatings, but there we were trying to develop a new deposition method. So I was really fortunate in my research. The objective on the technical side was to enhance the durability versus state of the art. So the material that they use to insulate the engines from that really hot combustion environment is yttria stabilized zirconia. And one of the newer materials was called gadolinium zirconate. And that material was great. It was a game changer. It can go to much higher temperatures, which then allows the engine to operate more efficiently. But the problem wasn't very durable. So my PhD really focused on how can we enhance durability of these coatings. That way they can last longer, we can implement them at higher temperature and ultimately have more efficient engines. So that's important for not only power and performance, but also for emissions. So it was a really interesting topic, and it was very fruitful research. I was very fortunate that I got to use these kind of large industrial scale systems. I've shown the NASA PSPVD system there, and to be kind of right on the cutting edge. I mean, it was a brand new technique. There's basically one and a half of those in operation in the US, and a couple in Europe and a few in China, and they've all just started in like the past 10-15 years. So it was very unique, and the research itself was very fulfilling. My work spanned nanostructural fundamental, where we're looking at just elemental modifications to reduce thermal conductivity of these materials and enhance durability, and then the physical nanostructure of the coatings, and then all the way up to more component and applied levels, where we're depositing coatings, we're putting them on components, we're thermally cycling them in an oven. I've showed some of that there on the bottom right. So being able to have work that has a good mix of fundamental and applied was really rewarding for me, and is something that I decided I also wanted to have that as I went forward. You know, I didn't want to just be applied, and I didn't want to just be in the weeds all the time. I liked having that mix. At the end of the day, I think, in my opinion, the research was pretty successful too, which I liked. I was able to be an author on 2 patents, one with Dr. Wolf and one with Brian and some NASA folks. And there were 10 publications that were a direct result of my work. So I really enjoyed the grad student work, maybe not necessarily the grad student life. The work-life balance is more or less non-existent as a graduate student, but it was helpful for me. That pushed me and really helped mold me into a much better professional, a researcher, and even person, and more disciplined person. One of the things that we were told that we should talk about and discuss is kind of our fondest memories of the university. So for me, I was there for 9 years. So you'd think like, all right, that might be challenging to pick from, but it's pretty straightforward. So my fondest memory is definitely my wedding. So I met my wife, Sasha, at Penn State. She was an incoming student the same time I was in matse. She finished her master's after 2 years. And then I continued on to finish my Ph.D. So as I walk across campus and go by the Pasquerita Spiritual Center and the Nittany Lion Inn, I have very fond memories of our wedding and of that special day together. But that kind of goes to the next part, and Kristen talked about this a little bit, but it's the 2-body problem. So now we have 2 career-oriented people holding advanced degrees. So it's no longer, well, this person's kind of the breadwinner and the other person follows. It's not that simple. Decisions when you're married, or in a long-term relationship, they become a team affair. So my opportunities were centered around the Northeast, to work at NASA Glenn or to work at some of the OEMs. My wife had a very fruitful career, was doing very well, and was established already in Houston. So we had to figure out, what do we want to do? And this goes back to having goals. Having the goals can help you choose that career path. And it really helped me decide what I wanted to do. I knew I wanted to do research. I knew I wanted, a mix of technical, but also applied. But I also knew that, I wasn't really focused on working for one particular company or one particular environment. And I had worked on small business programs as a researcher and really liked those, and had come from a family of small business owners. My father was, and one of my grandfathers were small business owners. So that kind of helped me decide what I wanted to do. I'd worked on these projects. I'd worked with companies who were doing this. I understood how it worked. And I decided with my partner, Jeremy Schreiber, to co-found Hammer Industries. So I started a business right as I finished graduate school. It was definitely kind of a harrowing time. You're scared, you're worrying, is this going to work out? Did I make a bad decision? Should I have just taken kind of the straightforward route of going to a company and somebody else tells me what to do versus I have to figure everything out? But I can say for sure that it was the right decision for me. And I've enjoyed every step along the way. The goal for our company was to develop advanced materials and manufacturing processes for extreme environments. And to do that by leveraging a combined experimental and computational approach. So every program that we do has an experimental side and has a computational side. I think that's really important and critical to be efficient in your research, and to honestly to have a good chance at developing something that's useful and commercializable. And for us as a small business, that's the goal at the end of the day. We want to commercialize the research. It might start very fundamental, but we want to have something that we have a path that can go to commercialization. And just some notable achievements. We started in the fall of 2016. By 2017, we had our first contract. And our first phase 1, both of them were transferred into phase 2s. And then our first phase 1, we've generated IP on that. So we've been pretty successful, and we were successful pretty early on. We have a couple employees now, and we're looking to continue growing this year, which is exciting. We have actually initiated tech transfer and commercialization on our first project. So I'm really happy with how we started. And like I said before, it's important to have dreams, and I have dreams of where we want to go. We've secured over $4 million in research funding so far. And we've actually subcontracted a lot of that. We've brought in over 1.6 million to Penn State. So I still work very heavily with Dr. Wolf. I work heavily with NASA and with other collaborators at Rice and elsewhere, and subcontract frequently. That way we can leverage the resources that the universities has. Being a small business owner, you realize that science isn't cheap. And a lot of these things are just not feasible for a small business. So things like SEM and all the tools that Penn State has are just not something that we could do on our own. So leveraging and having access to those university resources, absolutely critical, and having collaborators to work with. I'll be the first to admit, I am not an expert in a lot of fields. So it's it's important to have people that you can work with that, you know, fill out and have the expertise in the things that you don't have expertise in. So in being a small business owner, I've given a few talks on, you know, starting up and entrepreneurship. So I wanted to talk a little bit about just highlights on some myths of entrepreneurship in case someone is interested. If anyone ever has, or, you know, any questions or thoughts or intrigue on startup, working in a startup or starting a business, you know, absolutely feel free to reach out, and I can, you know, give you any information or anything that I've run into in my time. But there's a lot of cliches which have some truth to them, but the reality is often kind of starkly different. So I'm not going to go through all of these, but I think just remember that people tend to paint a very rosy picture about what it means to be an entrepreneur. But one thing I've found, especially starting a small business, is you have to wear a lot of hats, which means you have to spend a lot of time learning things that you didn't know before and that you may not have interest knowing. So I'm pretty sure that I'd be about 80% to being able to pass a CPA certification, just because I've done so much accounting and I hate it. But I have to do that. That's a very important part of my job. So beyond just budgeting, like at this point, that's easy, but accounting. So you do a lot of things that you may not want to do. You have to research and spend a lot of time doing things and learning new things. But at the end of the day, it gets you a lot of new skills, a lot of new things that you know and understand. So I do think it's fruitful, but it's important to know those things going in. So since this is kind of a broad open audience, I really can't get into a whole lot of technical detail, but I do want to share some of the work that we've done. Army, we've had projects ranging from optical limiter coatings for protection against high energy lasers. We've had thermal barrier related topics from Army, from DOE, and from NASA. We've had projects on lithium sulfur batteries, projects on advanced materials and dielectrics for testing methods for hypersonic applications, RF modeling tools for radomes, additive manufacturing for solid oxide fuel cells, for repair of spent nuclear fuel canisters. So we've had work that kind of spans a variety of different applications and uses, materials. The thing that kind of binds it together is many of these environments are extreme environments. They're all materials problems fundamentally, and we have a team that kind of has expertise in each of these areas. So I'm not an expert in all of these areas by any means, but we're able to assemble teams that have expertise, and each person kind of brings their own wisdom and their own knowledge and experience to that. So we've had some very successful projects. We have had really good success in developing optical limiters. We've been able to 3D print multi-layer ceramics using a custom in-house built 3D printer that's capable of large formats. So that's been enjoyable. We've developed oxidation resistant EBCs that have substantially improved performance versus traditional EBCs. And we've been able to deposit fully dense coatings using cold spray of some more advanced alloys, and been able to show that they have very high corrosion resistance and can be utilized in overlay applications. So we have a lot of other areas of interest. You know, any faculty members that may be interested in collaborating, there's kind of your place to look. So I'll finish up with the big dreams part of this. So small business from a small town and now big dreams. So for me, I think, like I said, everyone should have some goals. These are kind of some of our goals. So this is to grow the company, to continue commercialization, to start becoming a technical leader in some fields that we're interested for the company, and to start providing some enabling solutions that we can become known for. And then personal goals, I have 2 boys, so I just want to raise them to be good human beings, to be thoughtful, to be empathetic, to succeed maybe where I haven't, to become fluent in Spanish. My wife was born in Panama. We visit occasionally. I would like to be able to communicate better and not have to work through sort of interpreter of my wife or have those very low level conversations in Spanish. And we want to travel. Travel's a big thing for us. So combine that with our F1 hobby and look at a new country every year is kind of a goal for us. So with that, that's everything I have. Thank you guys for your time and hope there's some questions.
Great, thank you so much. Really appreciate it. So again, to the audience, if you have questions, you can type them into the chat or Q&A box or raise your hand and we'll read those off for you. So you talked about some of the myths in for entrepreneurship. So I was curious if there was anything, I mean, obviously it's very challenging to start a business. If there was anything that you found particularly surprising during that process that you hadn't thought of before and then kind of you had to deal with it later.
Yeah. So I think, and this will come from like the guise of we are focused a lot on doing things that are like federal contracting. And it's just the complexity that goes into starting a company that's going to do anything that's involved with the federal government. And that's that, everyone assumes that you've already done all of this before. So I didn't realize when starting up a company how much work was going to have to go into things that weren't technical and had nothing to do with what the company was actually doing. So I mentioned before about accounting. That's obviously a small thing, and you might expect that, but there's a lot of controls. We have to work and make sure that nothing is shipped by a ship that doesn't use a US flag. So it's just, there's hundreds of things like that that might be baked into your contracts that you're like, I don't know, how do I even track this down? So contracting with the government and all the things that go into that and how a small business manages that when you don't have a controls department and stuff, that was something and a challenge that I did not know about or foresee and had to work through. So I think, and that's for me and for what we've been doing, that's kind of one of the largest challenges. From the other side of things, I didn't really realize kind of how fruitful being a small business in our area would be. So the ability to still work with the universities and do kind of that fundamental in the weeds research is a lot of fun, and it's great being connected to people who are experts in their field and being able to learn from them, to work with them, but then simultaneously be talking to industry partners or have a vision on how you're going to commercialize this. So I knew that's what we wanted to do, but I didn't realize kind of how fun it is. So you get to sort of play in multiple sandboxes, whereas if you go right into industry and working for a company that's focused on one thing, that's what you're doing, that's what that company does, and that's it. We get to work in a lot of different areas, meet a lot of different really smart people, and it's very fulfilling.
Great, thank you. We have some questions in the Q&A box and chat, and then Val, do you have a question? With your hand raised, you can go ahead and unmute. All right, while we wait for Val, I'll go to the Q&A box. So do the computational aspects of your projects usually aim to help in the fundamental science or in the commercialization?
For us, it's the fundamental science. So for the optical limiter project that we're doing, we're working on different transfer matrix and scattering matrix and COMSOL, ANSYS approaches like that to develop and enhance the coatings that we're making, or in some way, shape, or form, it's either on the material side or on the kind of component functionality side. So it's definitely more in the fundamental science side of things, generally less so on the commercialization.
Okay, great. There's another question in the Q&A box. So what was your biggest challenge when it came to growing your business?
I think definitely one of the biggest challenges is assembling the right team and assembling a diverse team. Kristen talked about this before, the importance of diversity. for me and for us, it is critical as a small business to have a diverse team. So, and this isn't necessarily visual diversity or diversity at a high level that a lot of places like to brag about. For me, it's diversity of thought, and that can be from diversity of where people came up. It can be diversity of how people were raised, the culture that they've come from, the universities they went to, just the way that they approach problems. That's what is critical for us, because if everyone's thinking the same way and you can't come up with a solution and everyone else approaches the problem the same way, then we're not going to find a solution. And when you don't have too many people on a team, it's very critical that somebody can think outside the box or look at a problem a different way so you can find a solution. So assembling a good team, and we've done that, where we've started that, and I think we'll continue to do that. But assembling kind of the right team is a challenge, and I didn't know how to do that at first, and I kind of stumbled into somewhat to doing that. But now I understand the importance of it, and I see that as a challenge going forward to continue to kind of round out that team with different skill sets, different perspectives, different cultures, make sure that we have that diversity of thought.
Great, thanks. And then one last question is in the chat, which is related to that. So what type of openings does your company have now or in the near future? So if people are interested, do they just contact you? Is there a place they should go look?
Yeah, they can contact me directly. And then also we have openings on our website. We actually plan on revamping our website and our openings shortly, hopefully in the next month. But we are actively searching for some new candidates. Primarily, this is going to be on the side of additive manufacturing and on the side of high temperature materials towards hypersonics. So if you have any interest or any experience or background in those areas, those are people we're looking to bring in to round out our team.
Great, thank you. Okay,
Great.
so with that, we will end our Steidle Café today. Thank you so much, Michael and Kristen, for being here and taking the time. And thanks to all who participated. And we will see everyone in about a month.